Just basically dealing with the problem of I have an object that travels 1.39 meters horizontally in that amount of time. How fast is it going? Well, speed is distance over time. If I want horizontal speed, I use horizontal distance divided by time. The horizontal speed is 1.39 divided by 0.4549. That's meters and seconds. Around 2.9, 2.87.
Three
3.06 units.
meters squared. Or not squared, meters per second.
Okay, one of those S words. All right. Meters per second. That's the horizontal speed, and so therefore that is the speed when it is launched, because it is launched horizontally. Questions? This dramatic pauses for questions or for people to write stuff down. Complete?
So we would plug in those numbers to get our answer, or that's it?
Yeah, no, for the problem itself on the master set, instead of this, you put in 1.5, and instead of that, it was 8 point whatever, 8.2. For a master set, if you want to use 9.8 instead of 9.798, that's fine.
Okay.
On the lab, you would put in 9.798 with G. Other questions at the moment? All right, so let's take the second part where we're shooting it straight up. I'm now shooting something at 3.06 meters per second. How far up does it go? So I need to change this so it's pointing straight up. And now that's no issue. So first I'm going to eyeball it. Then put that, better to put on this side. Okay, according to this, it's now pointing straight up. Let me tighten this. All right, so now when I'm shooting it straight up, I do need to make sure that it is set at the same setting. I did short setting before, I have to do short setting now. One click, I can double check by looking at the yellow in the slit right here, and the yellow is on short. If I go too far, and I need to reset it, when it's like this, I have two choices. I can undo the clamp, I can then put it, and then dip it over, get the ball out, and then basically pull this. It says basically if you go too far, you have to pull this. Or launch the ball and just make sure no one's going to get hurt. Rules of lab safety definitely apply here. So the question is, how far up is it going to go? Now it is being launched from this height right here. Right now the ball is down here, but the spring is going to push on it, and we need to look at it from when only the weight is acting on it, which happens at this point right here. So the middle of the ball is at 26.5 centimeters. So when the ball is launched, 26.5 centimeters or 0.265 meters. And then it's going to go up to a certain height, and we want to predict what that height is. So let's do it experimentally first, and then we'll do the prediction. And I think Amina and Ms. Goff, you two have the best vantage point. I guess Isabel. We'll do a smattering of people, but I think you two have the best view.
I think, right here.
Ms. Goff, you agree? That's at 72.1. Or 0.721 meters. So the distance that the ball has actually gone up is this distance right here. It is 0.721 minus 0.265, whatever that difference is. Doing the fancy math, that's all done. 5 and 4. So it goes up 45.6 centimeters or 0.456 meters. The prediction is being shot at 306 meters per second. Or 3.06 meters per second. At the peak, how fast is it going? Somebody might have said it and I just didn't hear it.
Well, at its peak is not going fast at all?
So
Turn
what-
around?
Zero.
Zero.
Oh,
Yeah.
okay.
So it's going 0 meters per second here, it's going 3.06 meters per second. I'm trying to figure out what that distance is, so let's do time first. Let's figure out how much time it's going up. There are other ways of doing it. Actually, we could do conservation of energy. Let's do conservation of energy. At this point, how much kinetic energy does it have?
Zero,
Why?
because nothing's touching it. Because nothing's touching it.
No, not for that reason.
It's about to go back down. Cause it's about to go back down.
Okay, more specifically, it has no speed at that point, or 0 speed. So at this point, it's all potential energy. MGH. At this point, it's all kinetic, let's make this H is equal to 0. So it's all kinetic here, 1/2 mv squared. So whatever my kinetic energy is at this point is equal to my potential energy at that point. And for those of you who wanted to shout out 1/2 mv squared in unison, I'm sorry that I spoiled it for you. So my initial kinetic energy is equal to my final potential, assuming I say potential 0 here. So I got 1/2 times the mass times 3.06 squared equals my mass times 9.798 times my height, which is what I'm trying to find. We don't have mass, so we could just cancel it out since it's a factor on both sides, or make up a number. It doesn't matter what the mass is. I say let's just cancel it and make life a little bit simpler. So I got 3.06 squared divided by 2, which someone will share with me. 4.6. 4.68. And that's equal to 9.798 times my height. Divide by 9.798. And we end up with a predicted height of
How many decimals do you want? How many
let's go to
decimals?
3 decimal places.
4.78.
0.478.
Wait, yeah, sorry.
Units? What did we just find?
Is it meters?
It is. We found a height. So we predicted 0.478 meters, we got 0.456 meters. About 5% off. As far as problem 8B is concerned, you're just doing this part right here. Not comparing it to an experimental value.
So we would just put the velocity that we got from our equation, from the paper, and then do the,
Yeah, so
Gravitational.
whatever you got for part A goes here.
okay, and that's how we get the answer for
Yes.
each number.
And then whatever you use for the acceleration in part A, you would use that same number here.
Okay.
Questions at the moment? Yeah.
9.798 is gravity, right?
Acceleration due to gravity in Winston-Salem.
Oh. Then we can use that for this problem instead of 9.8.
Yes, that's perfectly fine. Other questions? All right, so what's about to happen is we're actually gonna do this lab. We're gonna head down to the other room. We're gonna go through the process. You get to go through the steps yourself, not using the boring old small setting or short range setting. If at some point, pretty sure it's this lab, where you're trying to figure out what's the maximum height that you want to send it, or what the maximum setting is. If at some point you think you're gonna hit the ceiling, you're feeling pretty sure you'll hit the ceiling, if you wanna hit the ceiling, go for it. Just try not to hit the plastic, hit the tile. But if you hit the plastic light covers, it would not be the first time.